Welcome to the first section in geometry. This section has a lot of definitions about lines, segments, rays, and planes. So we're going to start with those definitions. My goal for you today is I want you to be able to identify and name points, lines, and segments, and I want you to be able to find lengths of segments given some information about the segment. I also want to make really clear before we get started that the kind of geometry we study in high school is Euclidean geometry. Euclid wrote the oldest surviving mathematical textbook, and just so you understand, he was really focused on starting from nothing, deciding that there are some just given facts about the world, and then seeing what he could create using only those facts and logic. He was a very logical guy who wanted to start the world with just points, lines, and planes and see what facts could be drawn from those basic ideas. I also want to point out that Euclidean geometry is not the only type of geometry in the world. There are some other fields of mathematics that study non-Euclidean geometry. It's actually kind of surprising that Euclidean geometry is the geometry that we wound up really studying in mathematics because we live on a big sphere. Spherical geometry is very interesting in that you can have a triangle with two 90-degree angles on a sphere as long as your triangle is big enough. The reason that we use Euclidean geometry is because if you're in a very small portion of a sphere, it basically behaves like a flat plane. But Euclid decided that he was going to use a world where the plane is infinitely flat rather than a world where we live on a sphere. He probably didn't know we lived on a sphere anyway. There's another type of geometry that we're not studying this year called taxicab geometry. Taxicab geometry is the geometry of driving around city streets where you can't cut through a block. You have to stick to the streets in order to obey the laws of traffic. There are some interesting conclusions with taxicab geometry. We are not studying that this year, but just so you know, there's more than just Euclidean geometry in this world. So I said Euclid wanted to start with some definitions and then see what he could build from there. The first definition, he said, okay, I'm going to have something that's called a point. A point has location but no size. So the way I would name a point is with a single capital letter. These are some pictures of points. This is point A, point B, and point C. I want to point out that a point doesn't have to be pointy. This is actually a picture of an angle. A, B, C would be the angle, or C, B, A would be the angle. But the point would just be that location. That B would be a point. Okay. So we start with point. Point has location and no size. And then we also have a line. A line is going to be an infinite number of points, but it extends in two opposite directions. It extends forever, so it has an infinite number of points. It has no thickness because those points don't have a size. And the way we name a line is we either use a lowercase cursive letter, often an L, or we can pick 2 points on the line, any 2 points, and then put a double arrow on top of those 2 points. This would be line AB. That's what it looks like when we draw it out. We make sure we have arrows on both sides showing it goes on forever. We will be defining these next 2 words, in the next slides, but one thing that sometimes people get confused with is that a segment looks like a line, and we have probably used the word line to describe a segment before. Segments have end points, so they don't continue on forever in both directions. A ray is like half of a line. It continues on in one direction, but it has a starting point. We'll define those ones next. Before we do that, we're going to take a minute and I'm going to have you try these problems. So please pause the video here so you can try these 3 naming problems. When you have completed these problems, go ahead and restart. Okay, so number 1, as long as you used X and Y and put an arrow on top of it, you've correctly named the line. It doesn't matter what order you put X and Y in. Number 2, you can choose any 2 points to name the line, and then you put that symbol on top of it. Number 3, we only want to use 2 points when we're naming a line, and we want to use capital letters to describe points. So those are the correct answers there. Continue with definitions. So a line segment is the part of the line that's just between 2 endpoints. This does not continue on in both directions. We use a symbol with no arrow on those 2 points. For a line segment, we have to name the line segment with the 2 endpoints. We can put them in either order, but we have to use the 2 endpoints. So this is a picture of what line segment AB would look like. It's just a portion of line AB. And again, we want to make sure we know the difference between a segment, array, and a line. This is the definition of array. Array is a part of a line with one starting point but no end point, so it continues on forever in just one direction. The starting point and the other point on the array, the way we name array is with the starting point and then any other point on the array. We want to have a symbol with one arrow on top, and the arrow is going to point in the direction that the array continues on. So we list the starting point and then the other point. This is array AB. Notice that A is the starting point, and so if we name that, we would put the A first. Again, those are the differences between a segment, array, and a line. All right, so I'll give you a second to try these 3 problems, and please restart the video after you have given them a try. Okay, for these problems, if I want to name this line segment in number 4, I could change the order that the points are listed. For number 5, which is array, I can call it MO because M is the end point. And then for number 6, the only other name I can use is OE because I want to make sure that I start with the end point or the starting point and then continue on in that other direction. Oops. So a plane is a flat surface that extends infinitely. The way you name it would either be with 3 non-collinear points. That might be a word that you're wondering about. What is non-collinear? Non-collinear means that they don't lie in a line. So they are not in a line. Or you could use a capital cursive letter. It's different from the way we use plane in English. Math likes to do that. We take words that we use in English and then we use them in a different way. So just be careful of that convention in math. So here is a plane. One way you could name this plane is you could call it EAD. That would be a plane. You could call it NDI. You could call ND and I are not quite on a line, but if they were on a line, that wouldn't work. Maybe just to be safe, we should call it ADI, because those are definitely not on a line. Or we could call it capital letter K, because it is a plane. Okay, the thing that we've studied so far that has measure is segments. So we're going to really look at segment measure. Segment measure is the length of the segment. If our segment were on a number line, we could just subtract the distance between the coordinates and take the absolute value of that. 2 objects are congruent. So congruent is a new word. Congruent means that they have the same size and shape, although segments don't have shape really. They just have direction. So 2 segments are congruent if they have the same length. And then another new word here is midpoint. If a point is the midpoint of the segment, then the point divides the segment into 2 congruent segments. the two pieces have the same size, same length. The segment addition postulate says that if I have a point on the segment, I can add those two segments together to get the length of the entire segment. So that's what the segment addition postulate says. And that we can use to solve some problems. So if I want to find the length of segment CR, I know that CA is 6 and AR is 13. So CR would be 6 plus 13 or 19. Dumb thing. So here we know that BS is 10. So all the way is 10. And from U to S is 6. So that means that BU would have to be 4. So that 6 plus 4 can give you 10. So BU, the length of the segment BU, is 4. Another mathematical convention is if two segments are congruent, we put a little tick mark on them. So this little tick mark here is showing that these segments are the same size, which means that since AB is 2, BC also has to be 2. And then if I want to figure out the length of AD, I'm going to have to add up all of those segments. So I have 2 plus 2 plus 5. So AD is 9. And then on 14, the single tick mark means that HI is the same length as IJ. So that means that HI would have to be 4, just like IJ is. And then the double tick mark means that KL and JK are the same length. Oops, wrong color. So JK and KL are the same length, which means that this has to be 5. That's a little hard to see. And so if I want to figure out, so LH is what we want to figure out. Well, LH would be the distance all the way from here to here. So that would be 4 plus 4 plus 5 plus 5. So that would be 18. And then IK would be 4 plus 5 or 9. Okay. So that's how we that's how we use the angle addition postulate to find lengths of segments. All right. Thank you so much. Bye.